So for us, this is Unit 5, Lesson 5. Okay, so product of a binomial and trinomials. Remember, binomials 2 terms, trinomials 3. So this example here, it says a rectangle has a length of 5x plus 2 and a width of x squared plus 2x plus 1. Determine the area. Well, we know the area is just length times width. So we know that we're looking for, let's make this a little bit thinner if I can, right there. Okay, so we know that we're looking for 5x plus 2 times x squared plus 2x plus 1. Okay, and if you're not sure, I'm on page 299. So remember that right here, they're using the distributive property we talked about yesterday. So they're taking the 5x and they're timesing it to the whole thing. They're taking the 2 times it to the whole thing. Okay, we can also use a diagram. Our diagram, what's going to be different about our diagram than yesterday? 3 boxes, yeah, one's going to have 3 boxes. So our diagram, if you remember from yesterday, was, so we have 2 columns for the 5x plus 2, like that, and the other one's going to have 3. So it's going to be x, so what's in, it's x squared, 2x, and the 1. I don't have to put the plus signs because by putting them in there positive, that signifies plus. Okay, so we'll do it this way real quick. X squared times 5x, 5x cubed. X squared times 2, 2x squared. 2x times 5x, 10x squared. Should have made a bigger box. 2x times 2, 4x. 1 times 5x, 5x. 1 times 2, 2. So you can kind of see with this that it's kind of like diagonal can be put together. Those 2 diagonals can be put together. Okay, so these diagonals put together, I can't put anything with the 5x cubed, so I'm going to have a 5x cubed. Okay, I can't put anything with the 2, so I'm going to have a plus 2 on the end. My middle, 10x squared plus 2x squared, 12x squared. 5x plus 4x, 9x. And I'm done. That's it. Okay. Did I go too fast? If I did, sorry. Taylor, feel free to speak up. I know you were gone. A little bit. Okay. So then, now remember, I'm not doing a different problem. I'm just doing a different way. Okay. Now this you can also FOIL, which is kind of the same thing as doing this. Okay. Remember, FOILing is if you just go make sure that you multiply to everything. Make sure you multiply to everything, and then combine like terms. It's essentially the same thing as distributive property. Okay, so here, we're going to do it this way too. We are going to get the same answer. It might be redundant. I apologize. But again, 5x times x squared is 5x cubed. Then we're going to get 10x squared for this one. And then we're going to get 5x. That one's done. Plus, I'm going to move over here, 2x squared, 4x. 2 times 1, 2. Now combine all like terms again, and again we're going to get 5x cubed, 10x squared plus 2x squared, we get our 12x squared, 5x plus 4x, we get our 9x, and then our 2. And we can see that those are the same, which we expected. Okay. I'm probably very, for me, most of the time I'm not going to use a diagram. Okay, if you like the diagram, you can use it. Go for it. I prefer distributive property or foiling. Okay, but if you have a question about a diagram or anything, I'd be happy to answer them. Okay, any questions before we try a couple here? All right, so we'll go around and start getting people involved here, so I'm not talking the whole time. Okay, so, all right, so we'll start here. We'll just kind of go, Josie, so what's x squared times 2x? 2x cubed, sorry. What's that? 2x to the 5th, good. Okay, and then Chris, what's x squared times x? Okay, good. And then Taylor, what's x squared times negative 5? Okay, good. So that's our first piece. Okay, and negative 4 times 2x cubed? Good, Josh. Negative 8x cubed. Okay, negative 4 times x? Negative 4x. And Allie, what's negative 4 times a negative 5? positive 20. Good. Okay, so we got our list here. Now it's just the like terms. That's really kind of maybe the hard part. Now it's just finding stuff that's similar. So what's similar? There's no other x fifths. I have an x cubed and an x cubed. I have an x squared, and that's it. I just have one x squared, don't I? Did we even forget something? Nope. So I only have one x squared. I have one x, and then I only have one of these. So I only have two things I can combine. Okay, so that's going to give me 2x5, x3, negative x3, 8x3 is going to be a negative 7x3. So that's done. I'm done with this one, done with these. Negative 5x squared minus 4x plus 20. And we're done. Okay, so now, this one here, so now we're to Tatum. What's 2y squared times y? 2y cubed. Okay, what's 2y squared times a negative 6, Alex? Good. Okay, then we have Jad. What's negative 3y times y? Negative 3y squared. Good. And then back to the front. Josie, what's negative 3y times negative 6? 18y. Okay, and then we have negative 7 times y, Chris. Okay, and then negative 7 times a negative 6, Taylor. Positive 42, good. Okay, so now I'm going to combine my like terms again. Don't have any other y cubes, so write my y cube right here. That's done. I have a couple y squareds, negative 12 and a negative 3, so that's a negative 15. That's done. I have a couple y's, 18y minus 7y, that's 11y. And then I have my positive 42. All right, any questions yet? It's kind of pretty similar to yesterday, right? It's not much, newer is not a word, but not much different. Okay, just has trinomials today instead of binomials. Yeah. Yeah. It hits the product of these. So this is where we probably multiply these first and then times everything by 4. Yeah. You can, if you want to multiply it in early, you can multiply it just into one of them. You don't do it to both of them. Oh, but you can. Yeah. It still gets the same answer, yeah. Okay. Because if you put it into both of them, you're putting essentially 2 sets of 4s in, which we only have 1 set of 4s. We only have 1 4. Okay. All right, so let's try it. So, Josie, why don't you go ahead and try to do it your way, and we'll do it the other way, and we'll see, make sure it matches up. Okay? So, do it the way you said you're going to try it, put the 4 through. All right, so we'll distribute here. So, I'm going to get a cubed. Distribute here, negative 3a squared, and negative 6a. Negative 4a squared, positive 12a, positive 24. Okay, now I'm going to go ahead and put all my like terms together and times everything by 4. So my like terms are, I have another a cubes, 3a squared, a negative 3 and a negative 4 is a negative 7. So these are done. Negative 6 and a positive 12, 6a. And then 24. This is where I'm at. And now we're going to push the 4 in. 4a cubed minus 28a squared plus 24a plus 24. Okay, so that's my left side. Now I'm going to do the right side. Oh, yeah, 24 times 4. Thanks, Chris. Somebody's keeping track of my mistakes. 4 times 24 would be what? 96? Sorry, Thank you, Chris. Okay, so now we're going to FOIL out the right side. What do we know about the right side? Remember this pattern from yesterday? Yeah, they're the opposites, so what's going to go away? The middle. Good, good. So the middle's going to go away. Are you okay with me doing that, or you want me to do it all the way out? We'll do it all the way out because Taylor missed yesterday. So when there's opposites, okay, the middle ends up canceling, and we'll show you why. 4a times 4a is 16a squared. 4a times 3 is 12a. Negative 3 times 4 is a negative 12a. This is what we're talking about. Those go away. Negative 3 times 3 is a negative 9. So this is gone. So we have minus 16a squared plus 9. I put plus 9 because it's minus a minus. Okay, so that's how the middle goes away when they're opposite. Those are called conjugates or opposite of each other. Okay, so we finish it off here. I still don't have any other cubes, so I'm still going to have my 4a cubed. I have a negative 28 minus 16. That's a negative 44. And I don't have any a's, so plus 24. 96 plus 9 is 105. Okay, so there is your full best answer. Did you mess up? It's all right. We can look at it later. Or right now. Here's the second part. All right, so the second part of the lesson here, we're going to talk about doing triple binomials, okay, or 3 binomials. So we're going to have, and here's an example of, find the area, or excuse me, the volume of this box. So it has length, width, and a height. Okay, and so we would times it. What would the expression be to find the volume of it? It'd be length, width, height. We times all 3 of them. So in this case, we have 3 binomials, x plus 1, x plus 2, x plus 5, all multiplied. Okay, next example, which one's first? How do I do that? It doesn't matter which 2 you do first, but I would do 2 together and then go from there. So to expand it so it looks like this. Okay, and so what I'm going to do first is I'm going to go ahead and just do these 2 first. So that gives me an x squared plus 5x, 2x plus 10. Okay, I'll slow down a little bit. Is everybody okay? And then the 5x plus the 2x is 7x, and so I'm going to write as a 7x in here. X squared plus 7x plus 10, like that. Now you kind of see we're to what? What we were just doing on our previous examples. We're to a binomial times a trinomial. So now we're just going to do what we've been doing. So we're going to go here, there, and there. And the ones that hit everything, there. So we have x times x squared, x cubed, x times 7x, 7x squared, x times 10, 10x. Now we're switching to the 1. 1 times x squared, 1x squared, 1 times 7x, 7x, 1 times 10, 10. Do we just combine like terms now? Again, there's no other x cubed, so we're going to stay x cubed. 7x squared, 1x squared is an 8x squared. So that's done. These 2 are done. I love to cross off things as I go because it really keeps me organized in terms of what I'm combining, what I don't have to combine. Because now, and when I look at this visually, I see I just have 3 things left. I can only combine the 10x and 7x to make 17x. And so now these are gone. And then we have the plus 10. Okay. I guess we're going to do the y equals because we're doing expressions. It's just a habit, sorry. Any questions so far on any of that? Got anything, Jad? You all right? Okay. Okay. Why don't you guys see? We'll do A together, and let's have you guys try B. Oops. Oh, I did the picture thing, didn't I? Oops, sorry. I always forget I need to do the picture. All right. So example 5. Oops. Again, it doesn't matter which pair you do. Like for me, I would probably do these 2 first because they're easier because I don't have a 2x with them. Okay. Looks like these are going to be the same. Okay. All right. So x times x squared, x times 4, 4x, negative 3 times x, negative 3x, negative 3 times 4, negative 12. So my like terms there is 4 minus 3. So that's going to give me x. This is what we have. That's where we're at. We're to a trinomial times a binomial now. Okay. So now we're going to distribute again. And it doesn't matter. Again, like, you kind of notice that something to kind of pay attention to in terms of your pattern. Let's say you might think you forgot something. Can anybody tell me, after I multiply these, how many terms am I going to have? How many terms am I going to have? 6, right? How did you get 6? Right, and 3 times 2, right? So she's doing 3 terms times 2 terms. 3 times 2 is 6. So I'm going to have 6 multiplications to do. 1, 2, 3, 4, and then 5, 6. So you'll have 6 terms. So when you get your thing written out, you're like, that doesn't look right. Well, I have 5. I missed one. You can figure out, okay, what do I need to fix? Okay, so let's just go through this now. So x squared times 2x, that gives me 2x cubed. X squared times negative 1, that's a negative x squared. X times 2x, 2x squared. X times negative 1, negative x. Negative 12 times 2x, negative 24x. Negative 12 times negative 1, positive 12. And now it's like, look, I have 1, 2, 3, 4, 5, 6. That's what we're talking about, 6 terms. Okay, and then we're combining like terms. Again, there's no other x cubed. That's the highest one. Negative x squared, positive x squared. Negative plus 2. Negative 1 minus 24, negative 25. Plus, can't remember, what was that, a 12? Plus 12. Okay. All right, go ahead and try this one, and I want you to multiply these two first. Don't try that one on your own, try these two first. So let's see what to notice here. They're saying we're going to figure something out. So just going back around, so I think we were at Josh last time. So Josh, what's 2x times x? 2x cubed or squared? Just the first, yeah, just the first one. 2x squared, and then Breezy, what's 2x times negative 3? Okay, and then what's negative 1 times x, Allie? And then what's negative 1 times negative 3, Tatum? I called her by her favorite nickname. Okay, so then that simplifies down to what? 2x squared minus 7x plus 3. Okay, now we're ready to multiply it to the second one. All right, so Alex, what's 2x squared times x? 2x cubed. Jad, what's 2x squared times 4? What's 2x squared times 4? 8x squared. Okay, Josie, what's negative 7x times x? Negative 7x times x. Negative 7x squared. What's negative 7x times 4, Chris? Okay, I'm going to have to kind of curl this down here. I'm kind of around the room. And Taylor, what's 3 times x? Okay, and what's 3 times 4? 12. Okay, sorry, I had to bend that around. Okay, so our like terms, 8x squared, negative 7x squared, that gives me a 1x squared. We know there's no other x cubed, so we just write that. So those are done. Negative 28x and plus 3x is negative 25x. And then 12. And then what do you notice between these two? They're the same. They're the same. Why are they the same? Because multiplication, what? multiplication, order does not matter, right? 3 times 2 and 2 times 3 is the same thing. So your order of multiplication does not matter. Okay, and that would be it.